Thesus. I'm a software developer based here in Scotland, and during the day I work at a company called Digirati. We build some really great IIIF tools and products, and during some of my own time I also contribute and work on various open source projects within the IIIF ecosystem. Thesus is a project that brings together a lot of that open source work. This is Thesus. It's a IIIF viewer that you can paste a link to a manifest, a collection, or an image service. It has an overview of all the various content and IIIF features that this manifest contains, allowing you to quickly go to where you want to go. Or you can use the menu on the left to navigate. On this initial panel, you'll also see a few metadata items are picked out and displayed too. There's a deep zoom viewer, of course, and the controls and navigation. So what are the goals of Thesus? Why create a new viewer from scratch? Well, the first thing Thesus is trying to do is to be a useful reference when developing new IIIF resources or learning about what IIIF is. The second is accessibility. This includes being screen reader friendly, being available in multiple languages, having different color schemes, being available on mobile devices, and really removing anything that could be a barrier for someone viewing IIIF content. The third is compatibility. It should display as wide a range of different IIIF that is published as possible, both from online digital collections, but also handcrafted and unique resources. Next is discoverability. IIIF collections are a really great way of exploring large amounts of IIIF, but they are often sparse with only labels. Thesus will support a range of collection properties and explore ways to filter and search IIIF collections. Finally is the community element. Feedback, collaboration, extensions. I want this viewer to feel approachable to anyone who has ideas on how to progress these other goals. I'd like to show you how Thesus has so far tried to meet some of these goals. The first is accessibility. Everything in the viewer is keyboard accessible with landmarks for various sections in the UI. Every button and icon should have labels, which are all translated into multiple languages. When you load a piece of IIIF, it will scan for the languages contained and offer these as the first options. It should also detect your preferred language and use that first for both the UI and the content. It's available on mobile devices with a custom layout with all the same features hidden in an easy to reach menu at the bottom. The overview section has also been designed to be a human-readable navigation of the resource, giving quick, descriptive links to information that's available. For example, if the manifest doesn't have a transcription, then it won't be shown. Next is compatibility. The IIIF Cookbook contributors have done an excellent job in crafting easy-to-read and follow instructions on how to implement various IIIF patterns. Thesus supports all but 2 recipes and offers a single point of reference. Thesus also has quick links to a lot of other viewers too, if you'd like to view them there. Thesus can view common IIIF use cases such as books with transcriptions and tables of contents and different paging behaviors. It can also view AV resources with support for closed captioning in different languages and chapters within those resources. You can view geolocated IIIF resources, both with the navplace extension, but also with geolocation extension used by all maps to see historical maps next to their source IIIF images. This currently only works with all maps annotation URLs, but hopefully soon it will work with manifests with embedded annotations pointing to the map coordinates. You can view a wide range of annotations, regions, polygons, points, with embedded images, tags, or HTML. Soon you'll be able to filter and search through large sets of annotations too, useful for automated or machine learning outputs. This IIIF Presentation 3 manifest is one of the earliest examples of W3C annotations embedded inside of a manifest, handmade by the V&A Museum back in 2018. before the presentation 3 specification was finished. You can see the regions and embedded HTML that drove the guided tour in this particular manifest are still working and appear here. Thesus also supports image compositions and choices of images on canvases. This is a great example created by the team at the Getty Museum, showing one of the earliest photo albums ever made, recreated using multiple layers of IIIF images. You can flip some of the photos to see the inscriptions written on the back of them. Another example is from the Academic Heritage website at the Technical University of Delft. They have recreated their in-person exhibitions as IIIF manifests with photographs, objects, and rich, really detailed summaries on each canvas. Next is discoverability. Today you can open up any IIIF collection into the viewer. It will try to preload manifests to give you a preview of them if they don't have a thumbnail property. You can also bookmark manifests and collections saved to your browser. You'll see them on the homepage, where you can also find a handful of top-level collections available on the homepage. I'm always looking for new top-level collections to add to this page. One of the institutions that currently support rich IIIF collections already is Northwestern University Libraries. Their collections have labels, thumbnails, and even links to view the objects in their digital archive that Thesus isn't surfacing yet. And their collections also support pagination and using nested collections. Finally is the community. Thesus is a relatively new project. It will be open source next year. There is a GitHub for filing issues, feature requests, or just starting discussions. The next few months will be focused on the goals mentioned, gathering feedback, and prioritizing compatibility with existing IIIF that's been published. Over the past few months, I've had lots of productive discussions with people about Theseus and pages of notes and ideas that I'm really excited to implement. I hope you'll explore the viewer for yourself and see some of the features I didn't get around to talking about, and also share your thoughts and ideas for new features. Thank you.
Thanks, Stephen. And while that was recorded, Stephen is here. So if you have questions, save them for later. He will be here for the Q&A. Up next, we're going to welcome Jamie Folsom from Performant Software to present Recogito Studio, platform for collaborative annotation of IIIF images and more.
Thanks very much, Caitlin. I'm just going to share my screen here. There we go. Okay. Wonderful to be with you all. Thank you so much for the invitation and for your interest in Recogito Studio. So my name is Jamie Folsom. As Caitlin mentioned, I'm with Performant Software. We're a small company that does digital humanities software development. And we've had the pleasure of being part of the team working on and building Recogito Studio. You may recognize that word Recogito from a previous piece of software written by one of our collaborators, Reiner Simon, who also worked with us on this project. So this won't be a demo like the one we just saw of the Theseus viewer, but more just kind of a walkthrough of the features. We'd be glad to give demos to anyone who wants one anytime. There's also a workshop tomorrow that will be a full walkthrough of the software. So Recogito Studio is a platform designed for classroom teaching and has applications in other domains as well, but has support for IIIF images and manifests, among other types of content. So it's really more one of the features of the platform that I'll talk about. Like I say, it's designed for annotation in the classroom, supports IIIF images and presentation API manifest. So you can import a manifest and annotate that with your students or classmates. It supports TEI XML text as well, and PDF documents as a third type of document. It's designed to be easy to use, to be private, and to work in real time to provide real-time collaboration features. So professors can log in, create projects, and add documents and invite students. They can also group students and documents into assignments, kind of subgroups, to work on sort of focused, semi-private activities. And students can reply to the one another's annotations within the assignment that they're in. They can also see other annotations by students in other assignments as read-only layers on top of the same document they're working on. All of these annotations are web annotations, of course, so standard in that way as well. We have support for both upload of images, which are stored and served as IIIF images. Also import of IIIF presentation API manifests, as I mentioned, which are presented as composite documents. As I mentioned, support for TEI and PDF, and tools for each document type are provided. So you have text selection as well as polygon drawing tools and so on. Annotations for both TEI documents and PDF documents can currently be exported with those documents. So you can bring a TEI or PDF in, annotate that, and re-export it with its annotations. We're working on and planning to also provide support for creation of derivative IIIF manifests, which contain annotations created on those images for export and use outside the platform. As I mentioned, it's designed to be easy to use, work in real time, and to be compliant with the EU privacy standards, the GDPR standards in the EU. The interface is internationalized, so it's in German and English already, but will soon also be in other languages. It's accessible and responsive. We're very proud of the fact that we have support for keyboard selection of text, which I don't believe I've seen elsewhere on other annotation platforms. Screen readers also and tablets are welcome as well, so the support for tablets. We're about to release version 1.2. It's an AGPL licensed open source platform, so you can self-host it. It can also be hosted. We offer a turnkey hosted solution, which is inexpensive. And there's a plugin infrastructure which allows for extension of the platform. We already have a single plugin built for that infrastructure, which allows geotagging with any gazetteer source, GeoJSON, Pleiades, and others are already supported, and you can bring your own gazetteer. But we expect to build further plugins, as I'll mention in a moment as well. And anyone can do that as well. We also have support for SAML authentication, so you can bring your own IDP and authenticate your users that way. We plan to add that IIIF export feature I mentioned. We're in conversation with folks who are interested in machine-generated named entity recognition type annotations on top of texts or images, which would be presumably viewed in very much the same way that a read-only layer from another assignment would be viewed. So you can sort of look at that layer, turn it on and off, that sort of thing. We also are about to embark on building collections for art history instruction in the classroom. So you'll be able to build your own collections and annotate them and exchange them with students or professors. We will have a public roadmap available soon to share what's coming up, and we're always looking for new features that folks want to build. Partners and funders, really quickly, University of Bonn is the main funder of this platform, but we've also been joined, or they have been joined by the Cove Collective, which has adopted it for hosting and presentation of their content, which they license to libraries. And the Pelagios Network has also jumped in with funding for that geotagging plugin I mentioned. Exeter and Duke have just secured funding to build a plugin to talk to the Getty AAT and to shore up the plugin infrastructure as well. You can learn more about the platform at recogitostudio.org and also visit our company website at performancesoftware.com. And I will welcome your questions when the time comes. Thank you. Please feel free to contact me, Jamie at performancesoftware.com.
Great, thanks, Jamie. And I made a note in the chat that there is a workshop happening tomorrow. We had at least 2 late cancellations. It was originally sold out. So if you're interested in attending, just shoot us an email and we'll get you in. It's happening at 11 a.m. Eastern, 1600 UTC. Okay, up next, we have Mark Wolfe and Gregory Wiedeman from the University at Albany presenting One-Stop Shopping, the ArcLight integration project via IIIF.
Hi, everyone. And thank you so much for having me here and my colleague, Greg. My name is Mark Wolfe. I'm the curator of digital collections here at the University at Albany. We work in the M.E. Granander Department of Special Collections and Archives, and we're about 2 hours north of New York City, United States, about halfway up the Hudson River. Today, we want to do a bit of basically an overview of our project we're just starting. It's a grant project. We're just 3 months roughly into the project, and we want to share what we've done so far and what we plan to do. Our project background, our official name of our grant is Building Archival Digital Discovery and Access Systems with ArcLight. It's a 2-year grant. It's about $250,000 from the IMLS granting agency, as Greg Wiedeman, our PI and project director. The University at Albany and Empire State Library Network were awarded the implementation grant to further develop the software ArcLight. So it's something that's already been built and we're going to be adding on to it. ArcLight is a Stanford project. It's a black light-based discovery tool for displaying archival description. Our work will further develop ArcLight to provide discovery for metadata and, most importantly, for digitized materials and born digital for that matter. Currently, ArcLight is a discovery tool for only displaying archival description. Finding aids is mainly what we think of for archivists. The project is coordinated by Greg, myself, Jen Palmentiro at the Southeastern New York Library Resources Council, and we also have a graduate student here named Megan Slaff. Project is divided into 2 phases. Some of our project goals, inspired by the Stanford University's Lighting the Way project from 2019 to 2021, ArcLight's new unified search layer will allow one-stop shopping, hence the title of this presentation for users. It'll cut down and eliminate the need for 2 metadata silos, essentially having a digital asset management system in-house and also an archival discovery system. It will eliminate that to have 2 silos, for example, Content DM and ASpace. Consider the duplicative work that you can eliminate if you have just one discovery system. That's one of the things we're shooting for. We'll also be working with Empire State Library Network and the Connecticut Archives Online to ensure the project supports the work of consortial institutions along with their small and underfunded partners. We will work with medium-sized and larger institutions as well to ensure that the infrastructure we develop scales to support diverse sets of collections. One of the goals is to reuse archival description and allow for the use of minimal description. It'll allow archivists to easily describe large volumes of born digital and mass digitized projects. It'll allow for what we call extensible description in the archival field. It will lower the barriers for implementing systems for archival discovery and delivery. Using III manifest will simplify the digital infrastructure required for integrating archival and digital assets. And by integrating ArcLight and IIIF, we will create a single search platform for all archival finding age and digitized materials, hence the term one-stop shopping. Phase 1 will be a community development model and specs. We'll have a large cohort of remote week-long meetings in December coming up. There'll be 20 participants that will engage in facilitated discussions, and we'll aim to get participation from a range of archivists and digital library practitioners. We'll meet for 2 hours. For that 1 week, we'll meet 2 hours each day to gather all of our feedback. With that cohort, we'll enumerate terms and definitions that are germane to the work we're doing. We'll ask questions such as what are digital objects in the context of archival description, and what do we want to do with what will IIIF do for them? Because a lot of them are new to this, and so they're going to be learning about that as we go along. And we'll discuss examples of IIIF manifests. Phase one, from that large cohort, we'll have a small cohort of in-person meetings in February. 8 members of the large cohort will meet here in Albany, New York. We'll build on outputs of the large cohort meetings, a detailed draft of the conceptual model, combining archival description and digital objects, and then we'll develop multiple use case pipelines for harvesting metadata for adding objects into ArcLight. We'll draft a ArcLight IIIF specification, which will define how to use alternative representations and also provide access to text and content for manifests. In late spring of 2025, a possible reconvening of the large cohort and details have yet to be decided on that. For phase two, this is when more of the technology development happens. We will be reaching out to a vendor to develop a plugin / harvester for ASpace to export archival description into ArcLight. The ArchiveSpace plugin that will harvest data directly into ArcLight. And many people are excited about that tool. We'll develop the plugin to parse IIIF manifests included in the description according to the ArcLight IIIF specification and include full text content and digital object metadata in the ArcLight index. Phase two, UAlbany is currently using in-house tools to integrate archival description and digital objects, hence our interest in getting grant funding to do this project. UAlbany will build out its existing description harvester command line tool that will be used for the demo ArcLight instance, and then once it goes into full release. This will harvest description from ASpace's API, parse linked IIIF manifests for text content and metadata, and add that data into the ArcLight index using ArchiveSnake and PySolar. Finally, UAlbany, Empire State Library Network, and Connecticut Archives Online will complete 3 separate test implementations working with 6 different pilot partners. Instances of the 2 newly developed pipelines, one using the ASpace plugin and the other using the description indexer will be developed. Our project team is here at University of Albany. It's Greg Wiedeman, our PI and project director, Catherine Mules, me, and a graduate student I mentioned. And then I also want to give again a shout out to Jen Palmentiero, who's a digital services manager at CineArc, and Zachary Spalding as well. You can see our advisory board. Our pilot partners, we tried to have a range here of small to large. And I thank you. There's links to our project site. Thank you, Caitlin.
Great. Thanks, Mark. Okay. Up next, and coming from the absolute worst time zone, he's joining us in what is truly, truly the middle of the night for him, is Asanobu Kitamoto, presenting IIIF Curation Platform, recent developments to support large language models and the latest APIs.
Okay, thank you for introduction. Hello, my name is Asanobu Kitamoto from ROIS-DS Center for Connected Humanities. So I'm from Tokyo and it's now 3:30 a.m. So I'm trying to make a good presentation. The title of the talk is IIIF Curation Platform, Recent Developments to Support Large Language Models and the Latest APIs. And so my presentation is co-authored by Jun Homa from Felix Style. So we have been developing a IIIF Curation Viewer since 2016. So the important concept is called curation, which is a user-driven content creation to create your collection from multiple manifests. So this figure shows the example of how to create your collection. The first you draw a rectangle on the IIIF image viewer and add it to add two favorites here. And then you can create your collection, like a collection of face images from multiple manifests. So we create a data structure called curation, and this is unique feature of IIIF Curation Viewer or IIIF Curation Platform. So we have been working on this IIIF Curation Platform for 8 years, and we had a number of presentations in IIIF conferences like since 2017, and this is the 7th presentation about this IIIF Curation Platform. So we have a number of IIIF Curation Platform software. This IIIF Curation Viewer was the original software. So, and we create a new software, adding a new feature to the platform. And so today's topics is two. One is the support of large language model or LLM. And so this is about IIIF Tsukushi Viewer here. And another topic is support IIIF Image Presentation API 3. And this is this blue software in blue is supporting this IIIF Image Presentation API 3 now. So we'd like to talk about two topics. The first topic is support of large language models by IIIF Tsukushi Viewer. So this is a screenshot of IIIF Tsukushi Viewer. This is basically a IIIF Curation Viewer, which is IIIF Image Viewer. But the difference is that it has a generative AI chat window, so you can ask questions about this book. This book is written in old Japanese cursive script, so even native Japanese people can't read this book. So we applied OCR to this book, and then this text is used for the AI chat. So you can ask questions about this book, like explain the attraction for tourists, because this was originally a tourist guide. So you can ask questions like explain the attraction for tourists, and then the LLM can answer questions about this, like the text describes various attractions for tourists in Edo, now Tokyo. So this is like an interesting aspect of this software is that, well, this text is originally written in old Japanese, but you can ask questions in modern Japanese, or you can ask questions in English directly on this text without translations. So this is very useful for reading books for people who can't understand the text in this book. So IIIF Tsukushi Viewer, the purpose is to connect the generative AI large language model to the world of IIIF. And the purpose is to design a generative AI chat service to assist in reading books. So it is not a general purpose chat service. It's a chat service to assist in reading books. And we also offer multiple choices of LLM, including closed and open models, to explore the best model for classical Japanese, because we don't know which one is the best for classical Japanese. And we also focus on how to improve user experience and sustainable scholarly service, especially considering the high cost, because you have to pay for the LLM if you use closed models. So sustainable scholarly service is a very important goal of this project. And so how to design a generative AI chat for books? So we defined the prompt template as do X for Y, or select target Y and do action X. So this template is used throughout the chat service. So example prompts is like summarize the whole book or translate the page list. So in this case, the summarize is the action, and the whole book is the target, or translate is the action, and the page list is the target. So we always specify the target, and then the chat service can answer about the book. So the target is an information unit of books, and which is compared with the basic unit and identifiers of IIIF, which is explained in the next slide. And we also provide an action, a typical prompt like summarize, and which is included in the prompt library. So you can easily choose the summarize action from the interface. So we summarize information unit and IIIF. So information unit of books is like entire book or page list or image region, which is for visual chat. So IIIF unit and identifiers are corresponding to these concepts, like manifest is for the entire book, and manifest URI can be used as identifiers of the entire book, or the page list is list of canvas or canvas ID, and image region is a part of canvas, or you can specify it as using image request URI. So the architecture of AI chat is described in this figure. So, so you can input prompt here, and also you specify the target list of IIIF identifiers. And if you send this target list of IIIF identifiers to the content service, then content service has a transcription of the original book by Kuzushiji OCR. So you can retrieve the textual description of the IIIF identifiers in here. So you can combine the context of, you can use it as a context and then add prompt from user input text and then send it to chat service. And chat service communicates with LLM and then show the answer on the IIIF viewer. So this is the general description of the AI chat service. So we explain two services, content service and chat service. So Tsukushi content service is a RESTful API service for providing text by manifest URI and canvas ID. And when we specify manifest URI, it also provides book metadata so that you can ask about the book. And we also provide a text embedding model like OpenAI Text Embedding 3 Small for vector search. So this is useful for doing retrieval augmented generation. So you can ask a vague question and then text. You can apply vector search for retrieving related text from the book. And we use, for the implementation, we use PostgreSQL and pgvector for efficient hybrid SQL and vector search. So on the other hand, we design a chat service as a JSON RPC service for providing multiple chat methods from a single endpoint. And JSON RPC has three main parameters called method and parameter and ID. So method is used to specify the chat method, like combine the target and the action, like book chat or text summarize. So this is a chat service for the book and summarized service for the text or so on. And parameter is used for specifying the LLM model or its parameters or other parameters. And ID is used so that the same ID means a series of single chats. So if you want to refresh the context, you change the ID and then you can start a new chat. And the viewer also has an AI chat setting window and to offer a variety of choices for closed and open models. So you can see that Claude, GPT, those are closed models, and Gemma 2, Qwen 2, or those are open models. So you can choose various models. And to support the choice of the model, we show a guide, like 3 stars, like these 3 stars are the best model, and 2 stars might be a good model, and 1 star is not a good model. And we also set a quota for paid APIs like this, so that we apply a paid daily limit for this. This is because we want to make a sustainable service. We have to pay for the paid for the API, so we need to have a limit for the number of usage. Okay, so the final part is IIIF's presentation API 3. So as I described, we have started the development of the IIIF Curation platform in 2016, and this was the age of IIIF 2.0. So, but these days we receive a number of requests from users that why not support 3.0. But the RCP software heavily depends on the structure of IIIF 2.0. So this was a difficult part. We don't want to redesign everything from scratch to support 3.0. So finally, we reached a solution that we introduced a compatibility layer to convert 3.0 to 2.4 internally so that it works with 3.0 without so much redevelopment. And finally, we released TPIF Curation Platform 2.0. Yesterday, we released this major version update by finalizing the support of 3.0. So when the development of the 3.0 support, we relied on TPIF Cookbook. So TPIF Cookbook is showing, providing a number of good reference testing site for these 3.0. And so we tested this TPIF Cookbook, and we also discussed a lot with TPIF staff, especially Glenn Robson, to make sure that our support is really correct way. So, and then finally, so we had a very good discussion on the GitHub. So thank you very much. And the TPIF Curation platform, you can see you can also use these software from this website. It is open source MIT license. So you can, I hope you enjoy using this software. Thank you very much.
Thank you so much. And again, we appreciate you coming in so late to present.
Thank you.
Up next, we have Kiran Mohammadi-Williams from Cornell University presenting using IIIF as a one-stop shop for basic web literacy.
Let me share my screen real quick. All right, can everyone see that?
That looks great.
Great, thanks, Caitlin. All right, so my name is Kiran Mohammadi-Williams. I am the Collections as Data Librarian at Cornell University Library, and I'm going to be talking really briefly about using IIIF to teach basic web literacy. So when I started my position in Cornell University Library's Digital Scholarship Services Unit in August, I was assigned to work with a professor on finding a new way to engage students in his history course, which follows a series of maps as a centerpiece to sort of discover and analyze and trace patterns in American history. So in the past, the class had used Omeka to create multimedia essays that analyzed a selection of maps to reveal a theme about like pre-1900 American history. The problem, let's see if this works. Great. The problem was that Omeka was serving as more of a landing page for the traditional essay than as a transformative use of digital tools to sort of present a text and image-based narrative differently. So students were pretty much just writing their normal 2,500 word essay and then slapping some JPEGs on the bottom, and that was what Omeka was doing. And this was kind of a disconnect between text and image, especially for maps, which are objects that already rely on text-image relationships in these specific spatial patterns. So I really wanted to address that sort of disconnect. So my task was to teach a platform that wouldn't encourage sort of like DH for DH's sake or using digital tools just to be flashy, but highlight the ways that images could be used dynamically instead. And my supervisor recommended we use exhibit.so. So we selected exhibit.so because we wanted to leverage IIIF's capacity for such rich image presentation with maps. So the students were able to zoom in almost infinitely on these tiny details of maps, and that meant that their essays could be inextricably sort of linked to descriptions and specific points on the map. So for example, while discussing the shrinking boundaries of reservations established by like expansionist American settlers for indigenous people, students could set a zoom point in the viewer to display like that little red box of the settlement on the map at the same time. And so instead of having to download like 8 million images onto their computers and upload them somewhere, all they had to do was keep a handy list of these URIs. And it seemed like a great opportunity to explore a new platform and teach them something new. So as I was kind of working on the class presentation slides and my lesson plan, I started to think about what kind of data concepts I might be able to teach the students through the use of exhibit.so. Because I work in a digital scholarship unit, we are guiding students through how to use specific platforms, but we're also trying to brainstorm how we can promote critical data literacy in some way that they can take with them in the future past this course. So as I was looking through the IIIF documentation and I started to make my own sample exhibit.so project, I realized that which concepts I chose to share about data literacy and web literacy were really like my pick of the bunch. So to make them truly understand how to build a project from scratch in exhibit.so, we kind of needed to teach them about metadata. We need to teach them about URIs and URLs. We need to teach them what HTTP stands for, what it means to be interoperable and open source, how servers work, what an API is and how those work, what a JSON is, what's in a manifest file, and so much more. And it was also amazing to discover that most students didn't even know that they could use images through a URL. They thought that downloading was the only way to get images from one place on the web to another, like downloading from your local computer and then up into the web or something. So there was lots of opportunity here to teach a bunch of web concepts. So I ended up just picking a couple of these web concepts to focus on. And that was really building metadata and showing students like what metadata is and where it's stored in a manifest info.json file, and sort of the basics of how servers work, how things are served to the web, and how APIs play into that. So anyone who's ever taught anything like web related or tech related would probably tell you that one of the hardest things is getting students to believe that they can understand what's happening. Like they look at like this diagram, for example, at the bottom right here, which is actually like a really, really basic watered down look at how servers can work, and their eyes glaze over, they go back to online shopping on their laptops, they start looking at the clock. In short, they kind of have no faith in themselves to be able to understand what's happening, so they don't even try. And that's where I think teaching web concepts with IIIF specifically really has an advantage over other methods. And that's because the students can see everything, because it's a framework based around images, audio, media, things they can directly interact with. There's much more visual and sensorial interest to make them feel like the things they, are changing are actually changing, and they can see those changes happening. So I mentioned that one of the things I did was sort of show them with and there's a couple of server diagrams. So we went over a couple different, like the basic one all the way up. And so I sort of used like the way that the IIIF APIs work and trying to demonstrate how those work and changing things and showing them how servers sort of work on the inside to help them understand that. And they were able to see that when images changed or were served in different ways. But I also opened up a manifest file and sort of showed them what was inside it. And so I changed a piece of metadata in the file, or I like changed what image was on the canvas, or I added a new canvas with a new image, or recreated a new manifest. And I made most of those changes in like the file itself so that they can see how changing information that's read by a computer, changing the file itself, changes specific aspects of the way that that information is served, changes specific aspects about how that information is read by a computer. So we did this to image URIs, we did this for a bunch of different things. We tried out different viewers, and they were able to basically see how all of these components of serving on an image on the web happen in different ways. So when I went in for session 2, I was surprised by how much the students actually remembered. For example, they were all able to, without asking for help, go into the manifest they were finding on online repositories like David Rumsey and Library of Congress and find the manifest URI in the manifest file. Since exhibit.so obviously doesn't take uploads, it just takes, URIs and URLs. So they were able to say, like, doesn't look like this repository uses IIIF based on like a URL or URI for an image, whether it had some sort of nod to IIIF in, a specific part of that. And they were able to identify specific parts of URIs and URLs. And the absolute best part is that they were changing things. They were noticing differences between manifests and the way images were presented on different, viewers and on different servers, whether they were like IIIF compliant or not, depending on the server and the repository, and they were talking to each other about it. And so in just these 2-hour-long sessions, they had a decent, if not complete, because that's kind of impossible, understanding of how these images were being served on the web, what the heck IIIF was doing that's different from just uploading an image from a local device, and how cool interoperability can be for sharing things across the web in different ways. So originally in this lightning talk, I was going to talk about a second case study, one in the community. And while I still hope to use IIIF to teach some basic web concepts in a community space, something unfortunate happened that derailed a lot of those plans. And that was like Internet Archive going down, which is what I was originally going to use to make that a lot easier. Since the students are college students, they're capable of sort of understanding how to navigate GitHub. But I think for a community setting, you need to make it a little bit easier. So Internet Archive being down derailed some of that. But that is something I'm hoping to do in the future. And I think that if anything, it was another teaching moment, which was that to never rely on a single platform on the web, because things up there are not as permanent as they seem. So overall, I can't really think of a better tool, platform, software that can be used to teach such a wide range. As you can see on the screen, so many data and web concepts in such a compelling and above all else, like really physically engaging, sensorially engaging way as IIIF. From like, what does online mean to learning JavaScript and HTML, teaching with IIIF has the capacity to, I think, introduce both high level and advanced concepts to all types of students in accessible ways. Thank you very much.
Thank you. That was great. I fully expect that you will be getting a message from the IIIF for Education group who might want to discuss that some more. So we have some time now for Q&A. What I'll ask is if you have a question, feel free to unmute, but raise your digital hand so we can manage people. And if you don't want to speak, it is completely fine to type your question in the chat. I will read them out loud so everyone can hear them and for the benefit of the recording. So first, there's a question in the chat for Asanobu Kitamoto. What criteria are used to award the star ratings for each of the offered models?
Okay, thank you very much for the question. Yes, this is not based on the official evaluation of the LLM because we don't have a specific test data set for evaluating the performance of the LLMs for classical Japanese. So I manually selected few examples and then I kind of subjectively evaluated the performance of the output of the LLM. And then, so the 3 stars is really, so we don't evaluate in a very detailed way, like numerical evaluation. We just roughly evaluate them in 3 stars. So it's like, I think in the future, we need to do it more objectively, but for the moment, we just rely on a very small scale subjective evaluation. Did I answer your question?
Yes, thank you.
Okay, thank you very much.
Okay, other questions for Mark or Kiran, Jamie? Yeah, Anna Marie.
Hi, for the presenter on the Theseus viewer, it looks really exciting. There's a lot of great recipes that it works with according to the IIIF cookbook, but it looks like it doesn't rotate images. Are there any plans to integrate that capability into that viewer?
Not at the moment, but that it would be a good addition, I think. Yeah. I think the thing that stopped us adding rotation initially was the annotation support, and the sort of compositions just complicate the rotation. But yeah, I know there's a lot of resources like maps that need to be rotated in order to view them. So yeah.
Another question for you, Stephen. Can you embed Theseus?
In theory, you could, but at the moment, it's just the website at the moment. So I mentioned that it will be open source soon. at that time, it will also be embeddable, but with a different view specifically for embeds. One of the things that I've been experimenting with is not embedding a deep zoom viewer, but embedding an image that shows the IIIF before you interact with it, so that it's not a very expensive thing to embed on the page, but it's something that you could have 6 or 7 on a single page without worrying about the performance of the page. So that's one of the things I want to fix before enabling embeds and encouraging embeds in that way.
Okay, a couple more questions. One is, when will the code be accessible? But it sounds like it'll be soon. Couple more. What is necessary from an institution standpoint to have collections included in Theseus?
Ping me a message on the IIIF Slack, and I'll add them in. To no specific requirements. Just if there's a top level collection that Theseus supports, then I'll add it in very quickly. And if it doesn't support it, I'll fix it and then add it in. But yeah, the more collections, the better. So yeah.
Okay, and then one very specific question. What is the Places tab supposed to do on a manifest? And I should say nav place points seem to work in info, but Places is blank for my manifests.
So the Places tab, I think, is for nav place on individual canvases. So if Theseus sees that there is a nav place there, then it will load that sidebar item and try to render it. But if you do have a particular manifest that isn't working, then send it across, because a lot of the initial work was done using the cookbook examples. So if there's more examples out in the wild, then that would help with the compatibility.
Okay, question for Mark. It's too late to get involved in the ArcLight project as part of the cohort, right?
Yes, we've already selected ours. If for some reason we have a few that drop out, we might make another call, but no, we're set for now. Thank you.
Okay, I'm going to do just this one to Stephen, and then we'll go back. So a question for Stephen: can you speak about the technology stack used in Theseus?
I could talk about it for hours, but I'll give a very quick overview. So it's split into 2 segments. The first is sort of TypeScript models for all of the data. So parsing IIIF, extracting the features, finding the transcriptions, and that's all in a sort of event-driven JavaScript and TypeScript. And then the front end, which is separated, is written in React at the moment. But every sidebar and every sort of center panel isn't tied to something like TypeScript. And that was one of the things I really wanted at the beginning, sort of coming back to the approachability of the project. I hope that more parts will be written in different front-end languages, frameworks, and so there's no requirement for React. It's just what I'm used to, and all of the data is separate.
Great. Okay, a question from Ronald for Asanobu Kitamoto. Do you run any of the LLMs locally, or are they fairly reliable or have many stars? Did I say that right?
Yeah.
Ronald? Okay.
Okay, thank you very much for the question. I'd like to share the screen. Okay, so yes, we run local LLMs. Well, these are the list of LLMs that is provided so far. And these Claude and GPT is a closed model that we need to call API. But Gemma 2 and these after Gemma 2, these models are run locally in our GPU. So you can see that these 3 stars are only Claude and GPT. So those are good, but the local ones are worse than these closed models. And especially these Llama 3 is considered as a good local model, but it is trained for English mainly. So for the classical Japanese, it doesn't work very good. So I think it also depends on the language. But well, you can see that these local LLMs have worse performance than these very, very large models. So this is I think the current situation.
Thank you very much. That helps and understandable.
Yes.
Okay.
So it's good to have local LLMs because it is if you have GPUs, you can run it for free, but the performance is worse, and so I think it's a trade-off.
Okay, question for Jamie. You already touched on this, but could you contrast your platform further with other available annotation platforms?
Sure thing. Thanks for the question. So I think maybe the first answer to that is that it's really not our platform so much as it is a shared effort between University of Bonn and the Pelagios Network and the Cove Collective. We happen to be developers involved in it, and Reiner as well is involved. But it's so first of all AGPL, so it's open source, and it's really being kind of governed and run by the folks who show up and say we want to build features. That's important, very important distinction, I think, from other platforms. We also, so I think support for IIIF, support for TEI, support for PDF is a differentiator. There are platforms out there that support one or more of those, one or another rather of those formats, but don't yet have support for kind of all of those open standards. We also have the annotations themselves are web annotations. So they can be exported and eventually used in other platforms as well. There's a focus on instruction. I think that's a kind of built from the ground up for that purpose. So that's something I think that's perhaps a little different from other platforms. Those are a few things that come to mind.
Okay.
I guess one more thing, Caitlin, sorry to interrupt you. I just thought of, so there's one other thing that we're planning to build and we haven't yet done as much with is integration with other platforms. So if you have version controlled TEI tags, for example, those can be integrated for use there. And if you want to extract named entities and store them in a database and then use them to tag your annotations, that's the kind of thing that we have on the roadmap. All right, thanks.
Okay, other questions? I'll give you a few minutes in case folks are typing. I think that might be a wrap. I'll say, if folks think of a question later, please post it in Slack and we will, if the right person doesn't answer it, we'll get it to the person. Otherwise, thank you all for attending. Thanks for coming, even when it was inconvenient because you should have been sleeping. And we hope to welcome all of you again tomorrow. Like I mentioned earlier, we do have a couple spots for the Recogito workshop. Someone scooped it up during this meeting, but I would be happy to accommodate you. Just send a message to staff@iiif.io. And then after that, we will meet again same time, same Zoom room for another set of lightning talks tomorrow. Anything else before we say goodbye for the day?
Just a quick note of thanks. This is Martin Kalfatovic. I'm the IIIFC Managing Director. And again, thanks to all the presenters and all of you who attended, and looking forward to seeing you tomorrow.
Bye, everyone.